Okay, here we are again. We're going to take a look at the next series of questions in our guided notes. It has to do with calculating the number of atoms. This one is a bit trickier because our triangle here at the top doesn't specifically mention atoms. It mentions molecules. And molecules can also be, is the equivalent to, so if you see questions that talk about the number of particles or the number of formula units. If you see any questions in chemistry that ask for any of those things, they're the same. The number of atoms is a little bit different than that, and it can be equal to the number of molecules, but not necessarily. So let's take a look at this. Okay. But we still use this same triangle here to help us out. The one that has moles and number of molecules or particles, formulas or atoms. The numbers are very big. If you are given a question where it's talking about atoms, or they've given you, like in the next one here, where they've given you the numbers of molecules or atoms, the numbers tend to be huge, scientific notation, so you'll definitely need a calculator for this. Okay, let's see here. Well, the question we're going to look at first, actually I'm going to choose this one here because aluminum is a simpler substance than this mole of aluminum doesn't have as many different atom types as the calcium carbonate does in question H. So let's look at question H here first. Question H gives us only a little bit of information, 0.36 moles of aluminum. I'm going to go up and grab this triangle here, the one with my molecules and moles. I'm going to bring it down here so it's a little bit closer so we can refer to it. Okay, I'm actually going to draw it again as well. Okay, it's given us the number of moles, which is nice. 0.36 moles of aluminum. Okay. And it's asking us how many atoms. To calculate how many atoms, all we need to know is this constant here. Avogadro told us that there are exactly 6.02 times 10 to the 23rd atoms per mole. And because there's only a single atom type here, all there is aluminum, it's going to be as simple as taking 0.36 on my calculator and multiplying it by 6.02 times 10 to the 23rd. And you get the big numbers here. The number of atoms is equal to 2.1672 times 10 to the 23rd, and that is atoms of aluminum. Okay. Let's try letter G, which is similar. It's one step more challenging. Let's take a look at that one. Okay, so let me just erase what I have here. Using the same triangle. Okay, but it's a little bit different. Once again, it's giving me moles, so that's nice. I always like it when a question gives me moles. 1.45 moles. We don't know how many atoms that is, but we do know Avogadro's number, 6.02 times 10 to the 23rd. Atoms per mole. So I'm going to take my calculator, and because I know that this line here represents multiply, I'm going to multiply 1.45. Whoops. There's a mistake in the calculator. 1.45 times 6.02 times 10 to the 23rd equals. Okay. Now the number I get here is 8.729 times 10 to the 23rd. That is actually equal to not necessarily the number of atoms, but the number of molecules. Because I have several different types of atoms here. There's one calcium, there's one carbon, and there are 3 oxygens. So the total number of atoms in one molecule is equal to 5. This formula here actually calculates the number of molecules. So 8.729 times 10 to the third actually equals the number of molecules. Now the reason why it works in this one here is because there's only one atom type. So, I mean, if I took my answer from the last, from question H, and I multiplied it by 1, I would get the same answer. In this question, because there are 5 different types of atoms, I'm going to have to take my answer, which is the number of molecules of calcium carbonate here, and I'm going to have to multiply that by 5. Because that is actually the number of atoms in one molecule of calcium carbonate. So I'm going to press times 5. And my answer, my final answer that I get is 4.3645 times 10 to the 24th atoms in calcium carbonate. In the next video, we will try going back the other way, from molecules to moles, or from atoms to moles.